When using GitHub Actions, you may ask yourself, how do I make sure the latest code is being deployed to production, and only one deployment is happening at any given time? Or, how do I make sure the status check on a pull request is running only on the latest commit to the branch to try and conserve those precious build minutes? Let's see how GitHub Actions can help using the keyword concurrency. Hey y'all, I'm Mickey Gousset, and today we are talking about GitHub Actions, and specifically concurrency. How do we ensure with GitHub Actions that only a single job or workflow is in progress? Let's talk about a couple of scenarios where this might be important. First up is deployment to production. You want to ensure that only a single deployment is happening to production at any given time, and also that you are deploying the latest code to production. Second, let's say on every pull request created, you want to do a build and run a set of tests that take time to run. If a new commit is made to the branch, and therefore added to the PR, you want to stop the workflow triggered by the first commit and rerun using the latest commit, thus saving time and build minutes. This is now possible in GitHub Actions using the keyword concurrency. Keep in mind, this keyword is currently in beta, so its functionality and usage is subject to change. Let's see this keyword in action. So here we are in my experimentation repo. This is a public repository in my mickeygousset.org, so you're welcome to go check it out. This is where I just play around and do experiments. And in that repo, I've got a workflow file called concurrency-pr. Now, if we look at this workflow file, this is a workflow that I want to kick off when a pull request happens. So on a pull request to main, we're going to execute. I've given it a name. And as we mentioned, the concurrency keyword can be used at the workflow level or at the specific job level. In this instance, I'm using it at the workflow level. And I've defined the keyword concurrency, and then I've defined the concurrency group. So this is the unique value that's going to be used to determine whether I'm impacting concurrency or not. Now, right now, I'm giving that a distinct name, build and test. And in the future, we're going to show you how you could maybe tie this into, say, the branch you're on, something like that. But I'm just going to say group, build, and test. And you'll see I've got some other stuff commented out. We'll talk about that later. But for now, we have concurrency and we have group, build, and test. And then we've got my job, and I've got one job, which is to build and test on a PR. And that's going to run on Ubuntu latest. And I'm just simulating a build and a test, where I'm saying the build takes 2 minutes and the test takes 2 minutes. So anytime I create a pull request to main, this workflow should kick off. So if we come back over to code and we go to make a change, and we'll just say YouTube demo change 1. And we'll give this a commit message of the same name, YouTube demo change 1. And we're going to create this on a branch. We'll call this Mickey YouTube 1. And I'm going to propose this change. So this takes me to where I can open a pull request. And so title of the pull request will be YouTube demo change 1 and making a change. And I'm going to create this pull request. Now, when I create this pull request, if we wait just a moment, we'll see that it has queued up that build, all right, to run. And if we go over to the Actions tab, then we can see that the build is currently running, and we're currently in the build the code stage. Now, let's say I make another change on that branch. If I make another change on that branch, so I come out here and I edit the README file, and I'm going to say this is YouTube change 2, YouTube change 2, and I'm going to commit that change to that branch. That commit gets added to that PR, which would re-trigger the pull request action. And as you can see, it does. But whereas before the concurrency keyword, both of these would have been running at the same time. Now, because we have that concurrency keyword, the first pull request is still, or workflow is still running, while the second workflow is in a pending state. So you'll notice that it is showing up that this workflow is waiting on concurrent PR to complete before running. So it's waiting for the other workflow to finish before this workflow can run. And if we come back over and go back to that branch and make another change, and we'll call this YouTube change 3, and we'll commit this change. Then if we come back over to the Actions tab, you'll notice that our first workflow is still running. Our second workflow has been canceled. It has been canceled. And now our third workflow is in a pending state. So if we come back and look at our workflow file, in our workflow file, we defined at the workflow file level the concurrency keyword with the group build and test. So all three of these workflows, when they were triggered, had that same grouping, build and test. So the first one ran, the second one was put into a pending state as it waited for the first workflow to finish. And then because we kicked off the third workflow, while that second one was in a pending state, the logic is anything in a pending state gets canceled and the latest workflow is then put in a pending state. The idea being that you would only want the latest change to have the workflow executed. Now, if we come back out to our pull request, then we can see on our pull request, we can see the 3 commits that were made and that we are currently running a workflow, a check, with that first workflow file. You can see it's still running. And if we go to details, we can see that we're minute 32 seconds, minute 33 seconds in. So in about 20 seconds, this will be finished. And what we should see happen is the next workflow is kicked off. If we go back to the pull request, we should see nothing happen for YouTube change 2, but we should see YouTube change 3 be executed. And we can see that we have all 3 commits in this particular pull request. You can see that YouTube change 1 finished, nothing happened for 2, and 3 is now executing. So using that concurrency keyword, we were able to verify that it works as expected. If the first time the pull request workflow is executed, it runs, any future versions of that run with the same concurrency keyword or same concurrency grouping are either going to be put into a pending state or they're going to be canceled, and the latest one will then be put into a pending state. So let's go back to our code tab. Now let's see what happens if we come into our workflow file and we make a change. And in this case, we're going to continue to keep the group name of build and test. but we're going to add a second keyword under concurrency. In addition to group, we're going to add cancel in progress. Now, cancel in progress can be set to true or false. And the idea there is it should cancel the current build or cancel the current workflow and start the new workflow. So let's make this change. We'll save this change back to the main branch. And let's go back to our code tab and edit our README file off of the main branch. And we're gonna make a change here, and we'll call this change cancel in progress 1, and we'll give it the same commit message. And we're gonna create a new branch, and we'll call this branch Mickey/cancel in progress. And we will propose that change. And I'm going to create a pull request. Now in just a moment, we'll see that that workflow is going to kick off. So we can see that that workflow has kicked off, and it is currently in progress. So now, if we go back over to code and go to the cancel in progress branch, and we make another change, we'll call this cancel in progress 2. We'll give it the same commit message. And we commit that to the branch. What we saw previously is the first workflow continued running and the second workflow was put into a pending state. But now if we go look at actions, let's do a you'll notice that, and we saw it happen here. The cancel in progress was running when it realized that a newer version of the workflow had been kicked off with that grouping. Then it stopped this one and started the one with our latest commit. And if we go and look, you can see we get a message canceling since a higher priority waiting request for build and test exists. So we were able to say, hey, if we've got a long running workflow or whatever, and we've executed a newer commit, let's stop that workflow and start running this latest workflow. And that makes sense. Now, what happens though, since we have that group name kind of hard-coded, to be build and test, what happens if I come back to main and I make another change? So we'll call this change please work. And I commit that to a new branch. Create that pull request. Then what do you think is going to happen? It's going to start that workflow, another version of that workflow, another copy of it, and it's going to have the same group name as the one on the other PR. So what we're going to see happen is, if we watch here just a moment, this cancel in progress one gets stopped, and the one on the please work branch gets started. And if we look at this one that just stopped, it canceled because there was a higher priority waiting request. So this is where you've got to put a little thought into these group names that you're going to provide. Because the group names, if you're not careful, what just happened could happen. You could end up kicking off this workflow on a different branch and it stops the workflow on another branch. So how would we make this scenario work where it didn't cause the workflow on the first branch to fail because we started a workflow on a separate branch? Well, let's come out here and stop a couple of these actions. And we're going to come back over to our workflow file, and we're going to modify the group name. Now, when you're specifying the group name at the workflow level, you can only use the GitHub context object to provide variability in the group name. If you were specifying the group context or group name at the job level, then you would have access to all the different context variables that are there available to you, such as job, GitHub context, etc. But what we're going to do is we're going to create a new concurrency group. But this concurrency group is going to be tests on PR, and then it's going to use the head_ref object from the GitHub context, which is essentially the branch name. And we can see that by outputting, we'll add a step that outputs the head ref. But this means that the concurrency will only be checked against particular branches. So if we save this change, let's make sure we don't have any actions currently running, and we don't. And if we come back over and we go to the cancel in progress branch and make a change, and we commit that change, then if we go back to the pull request, cancel in progress, then we'll see that it has kicked off that action, and we can see that the action is running. Now if I come back to my code tab and I change to my please work branch and I make a change, will it work? And then I add a commit message and commit that change. Then if we go back to the please work pull request, we can see that the workflow is queuing up. And if we come over to the actions tab and we just sit and watch a second, we're going to see that these both stay in progress. Whereas before, remember, when we started up the please work workflow, it canceled the cancel in progress 1 workflow. Now, because we are using that group name that is based off of the branch name, those two group names are unique to each other. So therefore, they're not going to cancel each other out. So now I can have this same workflow that executes against multiple branches, and I don't have to worry about it interrupting the two different branches interrupting each other. We can see that if you output the head ref, see it's using please work. But I can still come back to code. I could still come back to my please work branch. I could come make another change. I think it will. I can commit that. That commit's going to go into that pull request. You can see there's the I think it will. And if we come back over to the actions tab, then we should see in just a moment the please work should stop, and this please work should kick off. And there you see it. So using the combination of concurrency group and concurrency cancel in progress, as well as using modifying the group name. I'm on the wrong branch here. Let's switch back over to the main branch. As well as modifying the group name to use the GitHub.head_ref variable, we're able to have a workflow file that always executes against just the latest version of, or the latest commit to the pull request. Now, one of the things you may have noticed is, as expected, the workflows come up as a check on the pull request, but I don't have any branch protection rules in place. So they're not required. I could still merge this even though the workflow hasn't finished running yet. So what if I want to make those workflows required? So let's say I want to make the workflows required, and so I want to add a branch protection rule to do that. How is that going to work with this whole cancel in progress thing? Is that still going to work as expected? Well, it should, but let's go check it out. So if we come back over to code and we look at our workflow file, we can see that our job name is build and test on PR. So if we go to the settings of the repository and we go to branches, we can define a new branch protection rule. So this is going to be on our main branch, and we're going to say require status checks to pass before we can merge, and we're going to select our build and test on pull request status check. So this is going to make that status, that workflow required to pass before the pull request can be approved. Now, this is kind of nice because we can require that the workflow pass, but let's say we have a really long build process and a really long test process. Rather than have the workflow file on the first commit run for 20 minutes while it runs the workflow, then on the next commit run for 20 minutes while it runs the workflow, using that cancel in progress, we can short circuit it and say, oh, that current commit's no longer the latest commit, so let's stop the workflow that's running, save those build minutes, and instead restart the workflow with the latest commit to the PR. For branches that have a large amount of turnaround on them, a large amount of change, churn, if you will, that's a great way to utilize your action minutes to their fullest. So if we come back over to our Actions tab, we'll see that currently Please Work is still running. Should be about done though, and it's finished. So we have our pull request right now. So I'm going to come back to my code tab, and I'm going to go to the Please Work section and branch, and I'm going to add just another change. And I'm going to commit that change. And because that change gets committed back to that pull request, it's going to kick off that workflow. You'll notice now I am an administrator, so I could override it. But if I wasn't an administrator, this would not be available to me, and I would have to wait for this check to run. You can see we're currently waiting for the ASDF check to run. And if we come over to Actions, and we can see that it is indeed in the build phase. Meanwhile, I go, oh, dang it, I need to make another change to that branch. So I can come over to this branch and I can add GG, good game, to this branch, and I can commit the changes. Now, because we have that cancel true, and we should see back on the pull request in just a moment, the ASDF one will cancel. The GG becomes the valid one. And at no point did we have the chance to just go to that pull request and merge it. It was a seamless little transition there. So it works as expected. Even if you're using this concurrency keyword to be able to control your flows, you're still going to be able to use branch protection rules to help enforce whatever your policies are as well. As I mentioned before, the concurrency keyword is available at the workflow level, so it applies to the entire workflow, but it is also available at the job level. So if we come in here and edit this file, then we can see at the job level, I can access the concurrency keyword. And it works just the same as it does at the workflow level, but only for a specific job. So that's a case where you might want to have multiple versions of the workflow file running at the same time, but you only want to have one specific version of the job running, like maybe the deployment job, something like that. So we're going to save exploring the concurrency keyword at the job level for another video, but I encourage you to go check this out. I hope you've enjoyed this look at concurrency in GitHub Actions. If so, please comment and like this video, subscribe to my channel, and smash that bell to be notified of my next video. Thanks for watching.